Welcome, my name is Scott Baker. This is the second in a series of Raven tutorials that is going to show you how to use Raven together with Sface to manage your slices and deploy experiments. One thing to note is the address of our website, which is raven.cs.arizona.edu, where you can find these tutorials and many other helpful links. So in the previous tutorial, which I suggest you do before this one, we installed three important packages called SFA Client, Sface, and Raven. Then we configured these tools by creating an SFI config file, and we installed a private key. So by the time we were done with that, we had a working SFA installation and a working Sface graphical user interface. We demonstrated SFA in the command line mode to prove that it was installed and to prove that we had all of the keys and config files set up properly, and we also showed that the Raven tool was installed. So again, if you haven't done these previous steps, please go back and read that tutorial, as that software will need to be installed and working before we start this tutorial. So in this tutorial, we're going to launch the Sface graphical user interface. We will set up an initscript for our slice so that Stork will be automatically deployed on our slivers. We will add some nodes to the slice, and then we'll create and publish an empty Raven experiment. Let's start by opening the Sface tool. So we'll do that by first opening a terminal window. Then in the terminal we can type in Sface. See, it popped up underneath the terminal. So there is the Sface graphical user interface. And we need to start by configuring it. Click on the Configure tab. Now you notice most of this is filled in. That's because we already in the previous tutorial created that SFI config file. The only thing that's not already filled in for us is the name of a slice. So let's start with a slice that I already have called plc.arizona.test35. It's one I created just a few minutes ago, and it should be a nice blank slice. So we type it into the slice HRN. We click Apply and Save. We can go back to the node screen, refresh our slice data, which will take a couple of minutes. So we can see several aggregates are listed here for this slice. We've got Planet Lab Central, Planet Lab Europe, Planet Lab Japan, and Vinny. We're going to create some nodes in PLC for now. It's important when setting up Raven to use with the Planet Lab aggregate that you set the appropriate init script. So the init script is a script that will run every time a sliver is instantiated. In our case, we use that script to automatically install some packages that are part of Raven that need to be deployed on these slivers. Those packages are the Stork and Tempest programs, which are used for us for remote software deployment. So we will click on the default tags for PLC, get down to initscript, type in Stork. Stork is the name of the part of Raven that is installed on the slivers. So we'll do that, click OK. We can expand this and see that initscript Stork is set to be added. Now it's time for us to pick some nodes. I'm just going to click a bunch of them at random. Double clicking usually works. Just trying to get a good set of nodes that are fairly geographically distributed. I'm also going to go pick a couple of nodes here in Oregon where I am physically located, and a couple nodes in Arizona, which is the home of the Raven project. That should give us a fair number of nodes. Once we have picked everything we want, we can click the Submit button. And Sface will compute an RSpec that includes these various tags and nodes that we've asked for, sends that RSpec to the SFA slice manager, which will go out to the aggregates and instantiate that data. Once it's been instantiated, we will download the replacement amended slice data, and it'll be updated in the window. So you can see that we now have 17 nodes selected. Our default tag is still there, and we're ready to do some experimenting. So at this point we would break and wait for these nodes to actually be instantiated. It can take a varying amount of time for the nodes to call into the Planet Lab node manager, download their update, and actually instantiate a sliver. While we're waiting for our nodes to be instantiated, it's a good time for us to acquaint ourselves with the Raven tool. The Raven tool automatically integrates with Sface. So if we look up here at the Sface tabs, we can find a tab called Raven. As we don't yet have an experiment created, it's time for us to create a new one. So we can go down here to the New button and press it. And then we will get this wizard that pops up and asks us to configure a new experiment for Raven. Now, Raven uses a directory-based experiment approach, so all of your experiment files will go in a particular subdirectory. Right now, it's picked my home directory, which wouldn't be very convenient for me. So I will change that to a directory called My Experiment, located off of my home directory. Once I have that typed in, I can click Next. So it does not already exist, so we will create that directory. Now we have an experiment name. So I'm going to name this experiment Raven Tutorial. And click Next. So the next thing the wizard needs to know is our private key. We already specified our private key in our SFI config file, so the wizard automatically knows where to locate it. We'll just leave the default and use that private key. It also needs a credential file. Credentials are automatically downloaded by Sface from the SFA server, so again, there's one already sitting there for us. So we've got one called smbaker.cred. We'll stick with the default, click Next. So we wants to know what slices we want to associate with this experiment with. We're working with Arizona Test 35, so let's continue to associate with that slice. Now there's some questions that everyone almost always answers yes to. So the first one is whether we want Raven to automatically manage our packages. The alternative would be doing it manually, which is an advanced option, which we may discuss in a later tutorial. We'll stick with the automatic default here, which is to let Raven manage the packages for us. So once Raven is automatically managing packages, there's three things that it knows how to install itself. So since Raven is automatically managing packages, there's some packages that it knows how to manage itself. These are the Stork Package Management Service, which is a key component to Raven. We probably want to keep that updated. The OWL Monitoring Service, which is used to monitor the state of slices. That's another useful one to leave. And the Kong Experiment Control Service, which is used to start and stop experiments and to collect results. We'll leave all of those enabled for now. And then we can click Finish. Now that we have created an experiment, the Raven main window is populated with several new controls. So we still have the Browse and New buttons if we wanted to create a new experiment again or open an existing experiment. We can see that we are currently looking at the Raven tutorial experiment. Now the key point of interest is this list here that specifies packages that we want to install. In addition to packages, it also specifies users that we trust. And we can see that we trust two users. They are Stork and Fedora 8. The way the trust model in Raven works is that trusting a user trusts all packages that that user publishes. So the Stork user happens to be the user that publishes Stork packages, which would be the Raven team, most notably myself and other people at Arizona. So by trusting the Stork user, we implicitly trust all of the new Stork updates. The other user that we automatically trust is called Fedora 8. And Fedora 8 publishes all of the Fedora 8 packages. They were downloaded from Fedora 8's Yum repository. By trusting that user, we are able to install any Fedora 8 package that we want using Raven. For the moment, let's not add any new packages, but let's publish our experiment. So go down here and click on the Publish button, and we'll see what happens. A lot of this scrolled up, so let me go back. So it starts off by trusting the Stork and Fedora 8 users. Then it builds a configuration RPM. So the Raven tool has an automatic RPM builder, and we use RPMs for packaging experiments and configuration information. So in this case, it packages up several of its config files into a Raven tutorial _ Raven config RPM, and that will be used to configure the parts of Raven that are sitting on your slices. Whenever that RPM is updated, it needs to rebuild the trusted packages file, so we can see that it now trusted the new RPM, as well as the Stork and Fedora 8 users. Rebuilt the RPM, finding it's already up to date. It signs everything, so Raven happens to use public key encryption, so we've signed a trusted packages file, and we've signed a configuration file. And then it connects to the Stork repository. At the Stork repository, it uploads the config file, the Raven config RPM, and the trusted packages file. And then finally, it's completed publishing. So right now, we've published sort of a blank experiment to our nodes, and this blank experiment says to trust Stork and Fedora 8 and to maintain those packages that were back in the configuration wizard, most notably the Stork packages, the OWL monitoring service, and the Kong experiment control service. As the final part of this tutorial, I'm going to discuss briefly the OWL slice management service. You can find OWL at owl.cs.arizona.edu, and there are several parts to OWL. One part is the OWL database and web server, which is hosted at Arizona. The other part is the OWL client, which runs on your Planet Lab or Genie slivers. The OWL client was automatically installed and maintained by the Raven software. So if you remember back when we created our Raven experiment, there was the automatic package management options, and one of those options, in addition to maintaining Stork, was to maintain OWL. As long as that checkbox was checked, OWL will be deployed on your slice. Now, you usually have to give it some amount of time before nodes will start showing up in the OWL database. I usually recommend about 15 to 20 minutes because we need to wait for Planet Lab to instantiate the nodes. We need to wait for Stork and Raven to get going on the slice, for OWL itself to get installed on the slice. Once it's up and running, your slice will be displayed here on the OWL index page. So there's Arizona Test 35. We can click it. And what we see here is a list of all nodes that are up and running OWL. We can see a few of the ones I remember adding. So there's a couple of Oregon nodes. There's a couple of Arizona nodes, and some of the other ones that I clicked at random. Now you'll notice not all of the nodes that I clicked on showed up here. That's probably because some of those Planet Lab nodes were down or experienced some kind of other problem. So looking at OWL, there's several important things here. So it is divided into major sections. So for example, the date received sections over here shows when these updates came in. We can see that this planetlab1.ecs.umich.edu, haven't heard from it in a while, so it has probably dropped off for some reason. Maybe the slice was deleted, maybe that node went down, maybe there was some kind of other problem on the slice. Got basic here, which tells the host name of the slice, and date, which is the date as it was on the slice itself. So this date over here is a server timestamp, this date over here is a slice timestamp. And then we have a bunch of other major sections, which a lot of these are things that we used internally. So for example, the dig dug service, the Kong service, latitudes and longitudes for the nodes, a bunch of interesting memory statistics, how much memory is used by various processes, the status of the OWL server, some Planet Lab statistics. Information on processes, so how many processes are currently running in your slice, how much memory are they using, what is the resident size, what is the overall size, information about SFA, the slice name, statistics about Stork, statistics about Tempest, that is our management service, the uptime of the node, and transfer statistics, so you can see which protocols were used to transfer files onto your sliver using Stork. And what's nice about OWL is you can extend this by writing your own little OWL modules to add your own major sections to OWL, and they can appear in the database. So this is a very nice, lightweight system for you to collect results and monitor your slices. For the purposes of this tutorial, we just wanted to demonstrate for you that you can use it to see that your slice did come up and that all of the Raven tools were installed and are working properly, because OWL is one of the things that is maintained by Raven. If Raven didn't work, OWL wouldn't be there and the node wouldn't have showed up. This concludes this tutorial. In the next tutorial, we're going to take the next step, which is going to be to start adding packages to our Raven experiment and deploying those packages on our slivers. This will allow us to actually accomplish some useful work. We will deploy not only pre-built packages, such as those in the Fedora repository or those obtained from other sources, but we will actually create a custom package with a very small Hello World type experiment, and we will see that package built and deployed.